So there's an unexpectedly close connection between the logic of mathematical concepts and the logic of informal concepts from common sense thinking. So what I'm going to do is develop some axioms of a plausible nature, and definitely an interesting nature about better than and much better than, which form a formal system in and of itself with no infrastructure. In other words, this is not on top of math. This is on top of nothing. Okay, that's a big point. This is not on top of math. This is on top of nothing. Okay, and it's a formal system, and we prove that it's equivalent up to mutual interpretability to standard formal systems that occur when we do the foundations of mathematics. Standard systems such as ZFC that we do in the ordinary foundations of math. Okay. Now I'm going to discuss in this is some discussions of of the notion of interpretability that's used as the yardstick. Now, how do you want to interpret these kinds of results? Well, it's not so clear. I mean, these are pretty new things. But one way to look at it is to say that, I mean, there are many spins you can put on this. One is that mathematics can be restated equivalently in terms of things that are far closer to common sense than you would expect. That's one way to look at it. That the intricacy and power of abstract mathematics is something that can be restated and recast in terms of ordinary common sense thought. Okay. Or you can turn it around and say, ordinary common sense thought has such complexity and intricacies that it's enough to completely subsume the most abstract mathematics we have. It's another way because we have mutual interpretability. Now, before getting into this, let me excite you a little bit, because you might want to ask, well, where can you do this? In other words, is this a very special thing? Is this only the subject, the only thing here is better than and much better than them, or is this, how broad is this? Well, here's the conjecture, that if you take any common sense ideas whatsoever that are not primarily scientific at all, and maybe even some that are, but say not scientific, any common sense ideas, then that lends itself to formation of very natural and simple principles of plausibility. There's a general technique for developing these simple principles, and these formal systems are mutually interpretable with the standard formal systems and foundations of math. Now, if you want to consider the range of informal conceptual ideas that are not in science, that's like considering the complement of a modest set, which is, the entire set theoretic universe. Your mother told you never take complement of a set, right? Because it's so huge. So therefore, what I am suggesting here by this conjecture is that this subject, the scope of this subject, is incomparably greater than the sum of all subjects that so far have been developed. Okay? So that's a pretty big subject. Now, to give you the idea of the scope of this, for example, you and me might be talking about restaurants, and I might say, or you might say, this restaurant is so much better than that one. This restaurant not only is it much better than that one, but it's so much better that it makes the comparison between these two other restaurants we talked about yesterday look small in comparison. So this is like a four-area relation, A, B, C, D, right? B is much better than, B is to A is much better than C is to D. Now this Sounds pretty complicated, but if you think about, just ordinary life, this is not the most complicated thing, right? In fact, it happens all the time. You want to talk about, is this restaurant worth this amount of money, these four-area relations, or maybe even perhaps more arity, occur naturally all the time. All kinds of convoluted, complicated things like this occur every day, when you just think about things. I could have had a list of these things. This four-area relation of, informal comparison between two pairs is totally amenable to this whole thing, and it probably has to rethink everything, and there's going to be all kinds of surprises and all kinds of different axiomatic principles that look interesting to look at, that you would come up with after being experienced in how to come up with these things. All kinds of things would come up just for that. So that's a lot of stuff. And so that's why I'm saying that the scope of this subject is just sort of incomprehensibly large. All right, but now I have to actually do something. So let's talk about what happened. So I wrote two papers, as I said. This one is the first one, and the second one is on universes. And then I have it came to me today an idea that's somehow even more fundamental in some ways even more fundamental and satisfying than either of these two papers, directly connected with Aristotle's principle of plenitude, which also comes up here. So some of this is, ancient philosophy is relevant, in ways that I don't know for sure, because I'm not schooled in, I haven't studied ancient philosophy very much, but I believe that, pretend that this is, this is thousands of years ago. Let's talk about it that way. Okay. I'll give you another framework in which I've been interested in doing this. Opinions. Okay, so redness. So there's a bunch of objects and there's a person, and then you can say this one's much redder than this one, or this is more red than this one. But then you can have a second person also making judgments like this, which are quite different. There may be serious disagreement. So you have multiple observers talking about multiple comparisons. And this gives rise to all kinds of additional things that don't occur in either of these two papers. It's somewhat orthogonal. So in some sense, you could view this as an intense theory of vagueness. Part of what I'm doing, and not necessarily everything. As an intense theory of vagueness where you actually have observers integrated into it. And I'm saying that very similar but different in detail principles immediately suggest themselves after you have looked at a few examples. One of the basic ones that comes up a lot is this plenitude idea, that anything you can imagine actually happens. This is an extremely important thing, and this is in fact the driving force between the comprehension or separation axiom and set theory. And this is vitally important, and this is embedded everywhere in this. Okay. It turns out that when you work this out technically, much better than is like a form of the power set operation when you finally do the technical stuff.